Let us look at the next section, students. This section contains 3 questions. The answer to these questions are in the form of double-digit integers. Let us look at question number 38. A sample solution of alanine from a fossil exhibits a value of specific rotation alpha to be plus 4.25 degrees. But the specific rotation of pure plus alanine is 8.5 degrees. The percentage of minus alanine in the given sample solution is X%. We have to comment on the value of X. Okay, so it is given to us to assume all the impurities present as optically inactive. Okay, so students, if we talk about the pure alanine, so pure plus alanine, it shows a specific rotation of 8.5 degrees. Okay, but the sample given to us shows a specific rotation of plus 4.25 degrees. So if we talk about the optical rotation of the sample, students, we can assume that X% be minus alanine. So the percentage of plus alanine will be given by 100 minus X. So we can now have the expression for the total optical rotation, students. So we have X into minus 8.5 plus 100 minus X into plus 8.5. This shall be equal to 4.25 into 100. So we can simplify this expression, students. We have 850 minus 17x is equal to 425, which implies that the value of 17x is equal to 425. So this means that the value of x is equal to 25. So students, in this given sample, 25% is the minus alanine, and since we have to report the percentage of minus alanine, we have to report the answer of this question as 25. Let us look at the next question now. Question number 39. The selectivity and reactivity of chlorine can be predicted by the percentage yield of the products obtained by the free radical reaction of Cl2 with an alkane. For example, we have propane. Propane is allowed to react with chlorine in the presence of sunlight to give us a mixture of compounds. So in the first product, the primary hydrogen has been replaced. So the amount formed is 42%. In the second product, the secondary hydrogen has been replaced and the product formed is 56%. Plus there is formation of some other products, okay, due to the free radical chain reaction happening, students. From the above data, it is calculated that chlorine atoms substitute 2 degree H from propane X times faster than they substitute the 1 degree hydrogen. We have to find the value of X. Okay. So students, if we talk about the propane which is given to us, students, if we talk about the primary hydrogen, so the primary hydrogen are 6 in number. So the 6 primary hydrogens are similar. So 1 degree hydrogen are present 6 in number. If we talk about the secondary hydrogen, there is only 2 secondary hydrogen which is present, students. So it is given to us that the reactivity of secondary to primary is X times. So we can have 2 into X divided by 6. Okay, so what we have done here is the number multiplied by the reactivity. So this shall be equal to 56 upon 42. So students, what we have done here is we have taken the number of secondary hydrogens, which is 2, divided by the number of primary hydrogens, which is 6 in number, along with the ratio of the reactivity of the chlorine with the secondary hydrogen to the primary hydrogen. So it is given to us as X in the question itself. This should be equal to the relative amounts of the products which are formed from the substitution of the secondary and the primary hydrogen given in the question. So students, if we talk about this equation, we can solve this. 2 will cancel 6 3 times, and 3 will cancel 42 14 times, and 14 will cancel 56 4 times. So we can clearly see that the value of X is equal to 4 in this case, students. So for this question, we have to report the answer as 04. Let us look at the last question for this paper, students. Question number 40. 2 moles of benzaldehyde react to give 1 mole of compound A using the cyanide ions as catalyst. Students, in the first reaction, the examiner seems to be interested in the benzoin condensation, students. Okay. When the compound A react with NaBH4 to give compound B, so the benzoin will get reduced by NaBH4. Okay. Compound B on further reaction with dilute H2SO4 leads to the formation of compound C. The number of different stereoisomers of B that can be formed is X, and the degree of unsaturation of C is Y. We have to comment on the value of X plus Y. So we have been told to assume the migratory aptitude of aryl group is more than an alkyl group, which is more than the hydrogen. Okay. So let's start with the reaction sequence, students. We have 2 moles of benzaldehyde. So we have 2 PHCHO. It is allowed to react with each other in presence of cyanide ions as catalyst. So we're going to have the formation of benzoin. This is the benzoin condensation, students. Okay. So this is compound A. Compound A is allowed to react with NaBH4. So NaBH4, students, is going to reduce the carbonyl group into alcohol. So we're going to have PHCHOH, CHOH and pH. So this is compound B, students. If you talk about the reaction of B with H2SO4, so it is going to cause the pinacol-pinacolone rearrangement. So we're going to have the formation of this compound finally. Okay. So this is the compound C which is formed, students. Now the examiner seems to be interested in the number of different stereoisomers that can be formed for B. So students, the number of different stereoisomers that can be formed for B are 3. So there are 2 chiral centers, but the compound is a symmetrical one. So there will be one DL pair, whereas the other compound will be meso. So total of 3 stereoisomers are possible for the compound B. So the value of X is equal to 3. If you talk about the degree of unsaturation in C, so if you talk about the DU, so there are 2 benzene rings present. So a total of 8 DU will be caused due to the benzene rings, and there is 1 carbonyl group present. So a total of 9 degree of unsaturation is present in this compound, student. So the value of Y is equal to 9. Since we have to report the value of X plus Y, the answer to this question is going to be reported as 12. This is it for today, guys. I hope the solutions were clear to you. Thank you.